I want you to look at 2.5, and actually this is quite a good thing to look at. This chart here, just example 1, we'll just look at the first chart. Some of you, when you look at a chart like this, some of you are not examining the differences. Some of you are looking, let's say you had a chart where you had 2, 8, 32, and you don't do, all you did was look at the chart and say, oh, these are all getting times by 4. You just looked at the output values, in other words, and said, okay, that means it's exponential. It's a geometric progression, so therefore it's exponential. I'm not going to argue with you about that as long as these are all evenly spaced over here, but that is going to be problematic. From day 1 in this class, we have talked about looking at the differences, not the actual y values, but how they differ from each other. So I want you to look in this first chart here. We got nice x's, which by the way always have to be a consideration. And then we have these random y's. Now there is no way that you are going to look at this and tell me what it is. I mean, there's nothing there. So let's examine the differences and see what we notice about them. Okay, so what have we got here?
6.
We have 6, 12,
24.
oh my. Okay, so now that's cool, right? This thing's going to be exponential. This is going to be exponential because why? The differences are proportional. Okay, now let's read the directions. For each, find a constant value that can be added or subtracted to reveal a proportional growth pattern, and then write an equation. Now, a basic exponential format is this. These numbers don't fit that pattern. Something has been added. I'm just going to call it C, or call it whatever you want, doesn't matter. Your job is to write an equation that looks like that fits these data points. Okay? And it's actually a lot easier than you might think. When you look at these differences, you notice that they're all going, well, they're being times by 2. So the ratio is 2. That means in your equation, your b value is 2. That's the ratio, the common ratio. Now, these numbers are not powers of 2. You understand that, right? But the differences here are going up by 2's. So that number is going to be a 2. Now, I know that if I put in 0 for x, I have to get 7. So if I put 0 in for x, then my y has to be 7. Does that make sense to you? Well, what's 2 to the 0?
1.
So 7 equals a plus c. Now guess what I'm going to do? There's 2 variables there, so what am I going to do? Pick another point and do the same thing, and I'm going to get another equation that has the same 2 variables in it. So let's just use the next one. It doesn't matter. I'll put in 1 for x and get 13 for y. So 13 equals a times 2 to the first plus c. So what's that equation? I have a plus c equals 7 already, and then I'm going to have 2a plus c equals 13. Can we solve that?
Yeah.
Yeah, pretty easily. So it looks like A equals 6. And if A equals 6, then C must equal 1. So let's look at that equation. 6 times 2 to the x plus 1. All right, let's just pick a random one. Let's put in 3 for x. If I put in 3 for x, I'm supposed to get 49, do I? Yep, there it is. That's all there is to it. Okay? Now, how did it all start, though? Where did we begin the problem? We began by getting the differences. I gotta find those differences. Okay, so look at the next problem and examine, this is table B. Find the differences and tell me if you can figure out your common ratio. What are your differences? 8, 24, 72, okay. So what's happening? They're all being multiplied by 3. So this guy right here, your ratio, your base, your proportion number is 3. The first point is 0, 2. So 2 equals A times 3 to the 0 plus C. Everybody figure out what I'm doing here? All right, let's clean that equation up. What does that equation really say? A plus C equals 2. And now I'll use the next one. 10 equals A times 3 to the first plus C. You can use any of the points in the table. I'm just using the first 2 because the numbers are smaller. So 3A plus C equals 10. And we'll solve that system however you want to do it. I got my A to be 4. Check that arithmetic. Does that look right? So now my A is 4. My B is 3. And I have to figure out my C. I know that A plus C is 4, or no, A plus C is 2. But A is 4. Yeah, I think you're right, Kennedy. -2. And then what am I always preaching at you to do? Test a point. Make sure your model is right. So if I put in 3, I'm supposed to get 106. So let's put in 3 and see what we get. 27 times 4 is 108 minus 2 is 106. Okay? You and your teammate do that last one. Julie and Luke, they're retreating, I think. And no. Is Julie on retreat?
Yeah.
And Luke?
Yeah.
And Ann? Okay, did you come up with it, guys? What did you come up with? I'll see if it's right in my way.
Y equals 64.
Y equals 64. That's what I got. Is that what you all got? Okay, so the moral of the story is, we keep getting these tables and we keep having to tell what kind of function it is. You want to look at those differences, okay? That's how you're going to tell. Not just from the output values, not just from the numbers in the chart, but look at those differences. If the differences are coming out proportional, but the Y values are not, then you know you've got some kind of translation and you're going to have to go through this process. Okay? All right. Let's take a look at example 2, which is taking us to our calculators. Read the problem in example 2. We're going to have an exponential function. It tells us that. F represents the number of fans. And T is T minutes. There are 47 people in the stadium 2 minutes after the doors open. That's an ordered pair. What ordered pair is that? Bless you. 2, 47. Perfect. That's X, that's Y. And then there are 2,602 20 minutes after the doors open. That's another ordered pair. 20, comma, 2,602. Now, you could do this problem by hand. They're not going to ask you to do that, but you could, because this is the equation. You know that if Y is 47, then X is 2. And if Y is 2602, then X is 20. Does that make sense to you? You could set these both equal to A, set them equal to each other, and solve for B. It's going to be a hideous number. You have to put it in your calculator and store it. But that is a very doable problem. We did some like that. He wants you to practice on your calculator. We might just do this by hand also. But let's do it on the calculator first. The key is they told me it's exponential regression. So I'm going to go to my calculator, and where am I going? Stat edit. And I've only got 2 points to put in. I'm going to clear out the old stuff that's in there. And I'm going to put in these points. All right, I got them in. Now what do I do? So now I go back into my stat menu, over to calc, and search for exponential. There it is. And I came up with 30.08 289 times 1.250, if I'm rounding to the nearest thousandth. Is that what you came up with? Use the given data to write two equations that can be used to find the values for constants. Did that. And then use your calculator to find the regression. Did he get the same answer he did? Yep, he sure did. We have time to come back and do that by hand. All right, do number 3. Same exact problem. Write your two equations that you would use to do it by hand, and then find the values of A and B using your calculator. Okay, did you get a regression equation? Okay, don't share it with me, I didn't type it in, I don't know, we're gonna do it by hand now, and hopefully come up with exactly the same, thing. So, did you get these two equations as your two equations? He asked you to write two equations, did you get those? Now, as long as you're allowed to use the regression feature of your calculator, then you don't even need those, you can just type in these points and get it, right? But if you're not allowed to use the regression feature of the calculator, then you're gonna be expected to do these by hand, but you're still gonna need a calculator. Because at some point, we're gonna have to be doing math like this, which is hideous. But what I did was, I took my two equations, and I chose to get A by itself. Now, these equations, it's exactly the same situation we had a minute ago. We have a system of equations, two variables. I eliminated in the last set because that just seemed like the easy thing to do. Here, I'm setting them both equal to A so that I can set them equal to each other. And then I cross multiply. And then I move some things around. So I divided this over to the other side and divided the b cubed over to this side. Ended up with this, which I'm in a minute gonna take the 5th root of. And hopefully when I do that, I will get the same b value. It's right here that you got when you did the regression. I got 0.699991194.
Yep.
So about 0.7. If I had to round it off, I would have to make it 0.7. Okay, and now I'm gonna find my A, and my A is 21.54 divided by that number cubed, right? So I'm not gonna store the variable. I could, but since I'm just using it right now, I'm gonna cube this thing and then do 21.54 divided by that answer. Did you get 62.801? 204? Perfect. All right, is everybody okay with that process? In case you have to do it that way. All right. Now we're going to talk about, whenever you talk about exponential growth and decay, you've got to talk about Euler's constant, the letter E. It's Euler's, this guy's name was Leonard Euler, Euler's constant. And it is approximately, I wonder if you remember, it's approximately 2.718, but it's an irrational number, just like pi. So you all know that when we say pi is 3.14, it's really more than that. E is really more than this, but that's, it's rounded off. Decimal. The number of bacteria in a particular culture can be modeled by the exponential b of t equals 17e to the 0.31t. Natural growth, like in a bacteria population or a people population, natural growth is generally modeled with a base of E. This is actually called the natural growth formula. Last year, I don't know if she ever did this, but did Mrs. Coors ever talk about PERT? Did you ever talk about that? No? Okay, we'll talk about that another time then. But that's E. That's your natural growth formula. And that's exactly what's happening here. 17 is the number that we are starting with. This is your initial value. This is your growth constant for this particular strain of bacteria. And then using that model, we can come up with whatever we're supposed to come up with. So it says, oh, wait, hold up. Question A, what is that asking for? This is the formula he's starting with. What does he want you to do in question A? Find, no, not in question A. He says we need to rewrite our formula with a new base. So instead of using E as our base, he wants us to use a different number. Anybody have any thoughts on that? You're gonna kick yourselves when you see how easy it is. Think about it for a second. Somebody in here knows. No? I'm coming up with a whole new equation. What if I found e to the 0.31? Isn't that the number that I'm raising to the tth power? So I'm going to find e on my calculator. Do you know where it is? Where's e on your calculator? It's the LN button, or for me, it's above the LN button. So if I just press that and raise it to the 0.31, I get 17 hasn't changed, but now the thing I'm raising to the x power or the t power is 1.363. Now, why would it be beneficial to write it this way? This is far more accurate, but why would it be beneficial to write it that way? What does this formula tell me that that one didn't? Well, for sure it's exponential. This is also exponential, but this tells me that my growth constant is 36.3%. Every minute or hour, I didn't read carefully, whatever the time unit is, this thing is growing by 36.3%. Do you see that? This did not tell me that. I had to calculate this to figure that out. These are the same equation. They will describe the same values. Okay, from Quinn, from you over, I want everybody on that side of the room to let T be 1 and find, basically, I want to find B of 1. You guys, I want you to find A of 1. All right, type it in, let's see. Now, they're not going to be exact because we have round off there, but I want you to see how close they are. Put a 1 here. All right, what'd you guys get over here on Quinn's side? You guys did this one, what'd you get?
Did we do that one or?
I got you got, I don't know, so who got an answer to this one? What is it?
23.17, or, yeah, 178.
178? All right, and what did we get over here?
23.171.
171? Okay, they're off a little, but we knew that would happen because I rounded that off. But these are exactly the same equation. Okay, they're gonna give you the same values. This one, you can tell what your growth constant is. All right, find the value of T when the number of bacteria in the particular culture is 1,000. So I'm going back to this one because this is more accurate. And I need to find out what T is. So I get 1,000 here. Okay? So here we go. I need to have 1,000 equaling 17 e to the 0.31 t. Any thoughts on how we could do this? We could definitely divide by 17. We could do that. And then, well, can we always fall back on graphing? Could we graph this as one equation? Graph this as the other equation, and then see where they cross? Would that work? That will always work? What's another strategy? Come on, you logarithm geeks. Anna? So we can take, since that's an e, I'll take the natural logarithm of both sides. It really doesn't matter. It just makes it easier if I ln in an e problem. So the natural log of 1,000 over 17 equals what? Anybody remember what's so cool about this? ln e is 1. So these cancel each other out, and you basically just have 0.31 t. Do you guys remember that? Stick that back here. It's so valuable, so cool. And then we'll divide by 0.31. That is a whole lot, for me, that's a whole lot faster than graphing, but That's because I don't have logarithm phobia. And I know some of you guys might. We're gonna have to get over it. So what'd you come up with? How long is it gonna take? What is this? Years or what? Measured in hours. Okay, how many hours? So there'll be 1,000 of them?
13.
Yep, about 13.144 hours. All right, we need to get through one more from these notes, and then I'll hand back some papers and we'll talk about some stuff. So one more, example 5. 50 deer were introduced into a large wooded area, and the model for these deer is this, and T is the number of years, and D of T is the population. Population of deer increases by 13% each year. Write an expression for D of T. Riley, you're writing away. What do you think?
Oh, no, I'm just waiting. But,
You're just doodling?
no, I think that, A and then like B is the 13%, so 0.13.
Okay, let's talk about that because that happens a lot. We'll say we're increasing 13%, so we put a 0.13 right there. 1.13. Because what's going to happen if you multiply by 0.13? It'll be decreasing by 87%. So we don't want to do that. So we're going to multiply by 1.13, perfect. And what goes out here in front? 50. Isn't that the initial value? That's the y-intercept. If t is 0, you have 50. That's the beginning value. According to the model, what is the population after 6 years? So in other words, what's d of 6? You just sit there and stare at me. I'm going to come unglued. Type this into your calculator. It is deer. So let's agree to round off to the nearest deer. 104, 5? Why are we arguing? Which one is it?
104.
104. Can we agree on that? Find the time t when the population of deer is 5,000. So we're using our same equation, but now 5,000 equals 50 times 1.13 to the teeth. I would, and I would do that no matter how I solved it, because if I divide by 50, then that's gonna shrink this number down, what is that, 100? And that's just gonna make my window smaller when I graph. It really doesn't matter if you're graphing. If you're using logs, you have to do that. But if you're graphing it, I think it makes it easier. So is everybody with me? Okay. Now, do I have some graphing people who love to graph? All right, Xander, you're in charge of the graphing. All right, so you're gonna graph this equation, this as in one equation, this as another, and find where they intersect. Okay? Do I have a logarithm lover? You can't be both. All right, I need a logarithm. Who's gonna do it? All right, Drew's gonna logarithm. So now the rest of you, pick one way or the other, and let's see if we can all come up with the same answer. Okay? So one way or the other, either by logging both sides or by graphing both sides, let's come up with an answer. Kyle, why are you sitting there? Are you done already?
Yeah, I did.
Okay, you already did it. Good. I'm gonna ask you for your answer. How did you do it?
I grabbed.
Graphed it? Sandy, you got it graphed yet? Almost. Okay, so Kyle, you graphed it. Xander, see if he matches.
Yeah, we
What did
matched.
you get? What's your T value?
We have 37.68008.
And what'd you get, Drew?
I got 37.68008.
How about that? And that would be yours?
That was awesome.
Isn't that awesome? That is awesome.
Together, yeah.
All right. Find an equivalent expression for D of T. So this is our expression right here. But I want an equivalent one where T is measured in months instead of years. Well, I heard some 12 T's and Patrick's up here like, so what's wrong with 12 T, Patrick?
It just doesn't sound right.
Doesn't sound right. And there's something to be said for that. Your gut feeling, you can, especially when you're smart, you can trust your gut. Raina,
Is it 1/12?
is it one, yes, I know
Or
anything,
T
I'm
divided by
sorry.
12?
I should have said something to you, they sent me an email. See ya, bye.
Yeah.
So our issues are we going with 12T or are we going with 112T? So let's talk about that versus this. Does it make sense to you that it's one or the other? Can you at least narrow it down to that? One or the other? Okay, so let's think about this for a second. Let's go with the top one. We know from our original equation that after 1 year in the original formula, we should have about 56 and a half deer. Okay? I know the half doesn't make sense, but we're in agreement. That's what's happening in this population. So if I come over here and wait 1 year, but T is measured in months, then that would have to be 12, right? T would have to be 12. And what's gonna happen is, I'm gonna have this many deer after 1 year. Is that what I want? That's way too many deer. That's a lot of deer. If I go with Raina's idea and say, I'm gonna wait 1 year, that would be 12 months. Would that give me the same answer as I know I'm supposed to end up with? Yeah. So Patrick, your gut was right, and Raina, your idea was spot on. Beautiful, beautiful, beautiful. So this would be your equivalent expression right here. That's your equivalent expression. Okay, all right, let's hang on to that. And would you get out your, you also have gotten back your, 2 point, I think it's the 2.2 that we need to talk about. And truly, I am questioning myself, so we need to talk about it together. Because like I said, half of you agreed with me, and literally about half of you all had the same different answer. So I wanna make sure that we can all get on the same page. So let's look at homework 2.2, problem 2, which is about the vines sprouting from the beans. All right, so vine A's length increases by 15 feet per day, and vine B's length doubles each day. So basically what we have going on here, we have an arithmetic situation and a geometric situation. The length of each vine is 10 feet when you start your daily measurements. And I think that is where the confusion came in, because I interpreted that as not at the end of the first day, but at the beginning of the first day. So I interpreted 10 as being basically a sub 0. I mean, that is the count at the very beginning of the whole thing. And I think others of you interpreted it as 10 was my first day's measurement. And now that I say it out loud, I think it can go either way. So if I marked yours wrong and you had like 500 million or some number like that, that isn't wrong. I get what you're thinking, and I have to be more clear. I was trying to be clever with the question, and I wasn't very clear. You see what I'm saying? You see where what I want to say, the ambiguity comes in? Okay, so we don't need to talk about it. If you got that 500,000 sum, you did it right. If you got the what I got, which was something times 10 to the 10th, you also got it right. It just depended on how you looked at it. That impacted your number 3, so if I marked that wrong. Now, those of you who said for number 3, will vine B ever be longer than A? A couple people said no. Why is that just plain wrong?
It's exponential.
And what do we know about exponential?
It gets faster.
Eventually, it may take a while, but eventually exponential is always gonna outpace linear. Always. Always, okay? So, I think some of you maybe graphed it and didn't see an intersection, and so you said, oh, they don't, but they do. Anybody get an answer there? Where do they intersect? About what day? We're gonna be off a little bit because of the ambiguity of the setup, but
134 days.
yeah, about 134 days. So those of you who said no, check that out and see if you get something like that. All right, is there anything else in that homework we need to look at, or in the next one, 2.3? Have we turned in 2.3 yet?
Yeah.
Have I given it back?
Yep.
Okay, is there anything in that one that we need to look at? Yep.
So, on number 5 on the front, since it's like,
Number 5 on the front of 2.3?
yeah, since the negative x makes it 1/2, and then on, like, the answer key said growth, why would that not be the same?
Okay, so this is number 5 on the 2.3 homework. Number 5 on the 2.3 homework. And all you had to figure out was, well, basically you had to know what it looked like so that you could answer the major. So let's talk about this for a second. First of all, what does this negative exponent do? Flips that. So this is going to be negative 2 1/2 to the x. Now, anytime your base is between 0 and 1, you are going to have a decay problem. Would you agree with that? what happens when you put a negative in front of it? It flips it over, so when I flip this over, it does this. Now, does this picture describe growth or decay? Are these numbers, is this thing increasing or decreasing? It's increasing, right? Now, in a real life problem, that probably isn't gonna happen because Y's aren't negative in real life. Y is how much is in your bank account, how many deer are in your reservation. Y's generally aren't negative in real life, but in terms of the picture, this equation demonstrates growth. On the left side, the limit is negative infinity, and on the right side, it is 0 on the bottom, right? So I get it totally how that can be confusing, but you have to pay attention to what's going on there, yes. All right, anybody else?
What's the bottom is considered growth, not decay?
Yes,
Okay.
because what does growth mean? Increasing. Increasing. But again, Xander, this is not gonna happen in a deer population problem or anything like that, because we don't have those. But in terms of that picture, yeah. All right, anything else? All right, I got a few more papers to hand out. I do wanna get your test back. We gotta get a couple more people to take it, and then I have 2 to hand back. I promise I'll do that as soon as I get, these people need to get this taken. Also, if you, have forgotten, your papers are due next Friday. Is that right? Yeah. Next Friday. So get them done. I don't hand those back, Bryce, until I pick out them all from the